Hey guys, this video is about solving a system of inequalities by graphing. And when I say graphing, that means by hand. So one of the things that I want you to be able to do is graph it by hand, but then also check it with a calculator. So in a different video, I will show you how to graph using a TI-84. So recall that when the variables of a linear inequality represent those real numbers, your graph solution is going to consist of a half plane and possibly the boundary line. So for two inequalities, the solution is the overlap of those two half planes. Recall that if you have a greater than or equal to, you're going to shade above the boundary line. If you have a less than or equal to, you're going to shade below the boundary line. The way to figure out if you have shaded in the correct direction is to use a test point. Test a point that is in that shaded region. Verify that it satisfies the inequality. If it does, then you shaded the correct direction. If it doesn't, you have to shade the opposite direction, because wherever you shade is where your solutions lie. I recommend using 0, 0 as long as it's not on the boundary line. If it's on the boundary line, then you're going to need to choose a different point. 0, 0 is just easy to check when you substitute it into an inequality. So let's go ahead and do an example. And for this, the direction is going to say solve the system by graphing. And the first thing I'm going to do is write down this system. So y is greater than or equal to negative 3x minus 1, and y is less than x plus 2. Okay, I'll go ahead and create my axes. And I am going to use red to graph this y greater than or equal to negative 3x minus 1. So with that, the slope here is negative 3, and that y-intercept is negative 1. So I need to plot the point 0, negative 1. From that point, I'm going to use a slope of negative 3. I'm going to go down 3, right 1. I could also go up 3, left 1. I'm going to do this several times. I'm going to look at it's a greater than or equal to. That means it's going to be a solid line. The solid line indicates all the points on that line are going to be solutions to the inequality. It is a greater than, so I shade above. Notice my test point of 0, 0 will work. I'm going to plug that into the inequality, y greater than or equal to negative 3x minus 1. So 0 is greater than or equal to negative 3 times 0 minus 1. Is 0 greater than or equal to negative 1? The answer is yes. So that means I shaded in the correct direction. The next inequality, y less than x plus 2, I'm going to graph it in blue. So my slope is 1, and the y-intercept is 2. That means I'm going to plot the point 0, 2. Use my slope, so up 1, right 1, up 1, right 1, or down 1, left 1 also works. I'm going to look, and it is a less than, so that is a dashed line. That means that boundary line, all of the points on that line are not part of the solution set. It is less than, so that I am shading below. All right, I've shaded them, or I've graphed and shaded each of them individually. Now I need to mark my solution, and I will do that in green. And the solution is the overlap. That is this portion right here. And keep in mind, it also includes this boundary line right here because it is an equal to. So that means anything on that boundary line is part of the solution. This dashed one indicates points on that boundary line, not part of the solution. So I typically will draw a line and say, well, that is my solution. Notice there are infinitely many solutions to this system of inequalities. All right, so let's take a look at another system of inequalities. And this example is going to have same directions, solve that system graphically, and the set is y greater than or equal to absolute value x minus 2. And then I have y is less than or equal to 4. Okay. Again, I'm going to create my graph. Okay. Looking at that y greater than or equal to the absolute value of x minus 2, well, an absolute value function looks like a v. So if I had y equals absolute value of x, I would plot negative 1, 1, 0, 0, 1, 1. Now, this absolute value of x minus 2 indicates I'm taking this graph and moving it right 2. So that means I'm going to add 2 to those x values. So this is going to become a 1. This is going to become a 2. And this is going to become a 3. So if I plot 1, 1, 2, 0, 3, 1, that'll give me that V-shaped, that absolute value shape. I need to look at the symbol, the inequality symbol. It is a greater than. If it's a greater than, it's going to be a dashed line. And it is greater than, I'm going to shade above. So let me get that dashed line in here, and what that means is that the points that are on this boundary line do not satisfy the system of inequalities, and shading above would be in this region. After that, I'm going to look at y less than or equal to 4. Well, if you wanted to graph, say, y equals 4, that's going to be a horizontal line. The less than or equal to means it's going to be a solid line, and it's going to be shaded below. So I'm going to go to 4. 1, 2, 3, 4. It is a solid line. Let me do this one in orange. 1, 2, 3, 4. Solid line. And it is going to be shaded below. My solution, I'll go back to my green here. My solution is going to be the area in which they are both shaded. It's both shaded in this triangle, and that is going to be my solution. Any point that is in the triangle is going to be a solution. So if you want to check to see if you have the correct solution, you could check a point that is in that overlapping region. So for example, I'm going to test let's see here, this 2, 2. I'm going to test the point 2, 2. And when you test it, you're going to substitute it into each of the inequalities. So 2 is greater than the absolute value of 0, and the absolute value of 0 is 0, and is 2 greater than 0? Yes. And the other inequality is 2 is less than or equal to 4. That is a yes. So with both of those being a yes, then that means that your solution is correct. So again, I typically will draw an arrow and say that is my solution. You have to somehow indicate that final solution. All right, so let's do one more example. And for this example, we're still same direction, solve the system graphically. I have y less than or equal to x plus 3, and y is greater than absolute value of x minus 1. So let me get my graph. And I will use red to do the first graph. Y less than or equal to x plus 3. That's where that slope is 1 and the y-intercept is 3, plotting that point 0, 3. I'm going to use the slope up 1, right 1, or down 1, left 1 to make more points. It is a less than, so that is dashed and shaded below because it's less than. So it's dashed and shaded below. Now let me get the blue color here, and we'll do that with the second one. And this is an absolute value. Again, we just did an absolute value, and our points for absolute value are negative 1, 1, 0, 0, 1, 1. And with that, this absolute value x minus 1 indicates it's moving right 1, which means I need to add 1 to each of the x values. So I'm going to plot 0, 1, 1, 0, 2, 1. Notice it's going to give me the v, and that's what an absolute value is. That's where all of your y values would be positive. So I've got my v. It is a greater than. If it is a greater than, it is a dashed, and it's going to be shaded above. So dashed, and shaded above. There we go. Now, my final solution, I'll do in green, is where they're both shaded. So notice this includes no boundary lines as part of your solution set, and it includes all the points that are in this green shaded region. That is my solution. So if I wanted to do a test point, if I want to test, let's find a point that's in there. Let's see, 2, 2, 3 is a test point. And I'm going to substitute it into each. 3 less than 2 plus 3, and 3 greater than absolute value 2 minus 1. See, 3 less than 5, yes. 3 greater than absolute value of 1, 3 greater than 1, yes. My test point works. That means I shaded in the correct direction. So guys, that's how you are going to solve that system of inequalities by graphing.